Good morning and happy Wednesday. We are going to continue with vectors today. Of the people that submitted their homework, you guys did a really good job. I just wanted to point out one thing on one of the problems. So I went ahead and showed you that H, the components were over 7 and up 5. Because we go to the right and then up, they're both positive. So it should look like this. The magnitude was root 74, and then the degrees or direction was 35.5 degrees. We didn't have to do any of the subtraction or addition from 180 or 360 because it was in quadrant 1. If sorry about that. If it were in a different quadrant, we'd have to do a little bit more work, but it is not. Okay? All right, so the same goes for W. So here are the answers for W. The only thing that I saw wrong on a couple of people's is the negatives. Okay, so on W it goes to the left. So because it goes left, that direction, we need to have a negative, and then up is still positive. Okay, so we always want to start at the initial point and work our way to the terminal point, which is the end point, which would be here. So we want to go left or right first. So that's negative because it's to the left, and then up. All right, now it is in quadrant 2. So our answer should be somewhere between 90 degrees and 180 degrees. I have already worked it for you here. And again, everybody got that right, actually. The only discrepancy some of us had was rounding, but we're going to round to the tenths. Some people just rounded it to the hundredths, but y'all all did very well on that one. I am going to work K, however, because K was missed a couple of times. All right, so let's discuss with K. We're going to start here. We're trying to get to this point here. Okay, so we want to go right or left first, so we have to go left. So what kind of number should that be? That should be a negative. So how many? 1, 2, 3, 4, and then we go down. Down is also negative. Okay, so our component should be both negative, and that should make sense to y'all because remember in quadrant 3 both of the x and the y values are negative. Okay, so that should be negative 4, negative 2. Let me make sure I had that right. Yes. Okay, now this part I don't think we had issues with. Everybody was okay here. Oh, actually there was an issue. I'll show you. When you square these, you get a positive. Now some of you left it root 20, but that is not simplified. Okay, so which perfect square goes into 20? It's 4. So the square root of 4 is 2, 5. That's the best answer. Okay, now I'm not really going to be super picky because root 20 and 2 root 5 are the same thing. It's just the root 20 the 2 root 5 looks better. Now I will say when you come over here and do sine, so that's going to be our opposite side, which was negative 2, or our y over, now I'm going to use root 20 instead of 2 root 5. It's just less to put in and less parentheses we have to put in, so just FYI. Okay, so then we'll have you do get a negative, but remember we said just take the absolute value, so it's approximately 26 point, what is that, 26.6 degrees. Yes. Okay. And so now I know that this is not in quadrant 1. What quadrant is this in? Well, because they're both negative, it's in quadrant 3. Okay, so in quadrant 3, let's go over here. It says we want to take 180 and add it to our theta prime. So to find theta, we're going to do 180 plus the 26.6. And so then 180 plus 26.6 gives us our 206.6 degrees. And then you can kind of make sense of it. Does that look like it is, it from here, does it go around 206 degrees? Yeah, because this is just a little bit past 180, not much, and that's about 20 degrees, 26 degrees to be exact. So that's how you do that one. So just be careful for your negatives. If you look here at V, it's a positive and then a negative, so that means it should automatically be in quadrant 4, you know, because if you go to the right and then down, and so you can kind of notice, yes, it is in quadrant 4. All right, these are both positive, so U should be in quadrant 1. These are both positive, so H should be in quadrant 1. These are both negative, so quadrant 3, etc. Okay? But for the most part, very good on your homework. Here are all the final answers, though, if you want to take a moment to look at them. And now we'll kind of move on with our vector operations. Okay? All right, so vector operations, it's pretty easy because it's going to be just very much algebra based. So we have two operations. We have scalar multiplication and we have vector addition. In operations with vectors, numbers are usually referred to as scalars. Okay, so you'll hear me say scalar multiplication. It basically just means we're going to take a number and times it to a vector. Okay, now I think this image is very important. Okay, it says, when a vector is multiplied by a scalar, the vector becomes k times as long. All right, so let me show you visually what that means. So here is my original vector v. All right, so it's some distance. It's, you know, 2 of these lengths. And it's pointing in, you know, like the north, what is that? East direction, okay? Now, if you look at this next one, this one says 2v. Okay, so that means twice the length of vector v. So do y'all see it is literally, there's 1v, and here's 2v. So it's literally 2 of these just copied over here. Now, did we have to put the arrow in both places? No. So it's like 2 and then 2 more. So that's why it's 2. So you could see 3v would be, you know, here, here, and then 2 more. That would be like approximately 3v. I'm not obviously perfect, but doing my best here. Okay. Now, what happens with the other one? So this one right here says half v. So basically it's going in the same direction, it's just half as long. Okay? Now, what do you notice about negative v? So it hasn't changed length at all, it has just changed direction. Okay? So that's what this is saying in the next little blurb. It says, when k is positive, kv has the same direction. When k is negative, so when your scalar is negative, it has the opposite direction. So we have our arrow pointing downward as opposed to upward because it's a negative. And then our last example is negative 3 halves, which if you know you do. Negative 3 halves is negative 1.5. So it's 1 vector length and then a half more, and then it's going in the opposite direction because of the negative. Okay, so visually I just think that's a good little picture of what positives and negative mean with vectors. Okay, so with scalar multiplication, it is essentially the distributive property. Okay, so if we have k times v, which is k times any vector, we're just going to times it to each of the components, and then you'll end up here. Okay? To do vector addition, you're just going to add the components, which is you're going to add the x's to the x's, and you're going to add the y's to the y's. Okay, so here's an example. Here's a vector u, here's a vector v. If we want to add them, we just literally add the x plus the x, which gives me this, and then we're going to add the y plus the y, which will give me this. Okay, now it'll make a little more sense in a second when we do actual numbers. Okay, and then if we negate a vector, it literally just changes the signs. Okay, so if they were both positive, they're going to be both negative. If one is positive and one is negative, then those two would switch. Now, we do not have vector subtraction. Okay, we only have vector addition. So you see how it says the difference of u and v is u plus. We put it in terms of a positive. But as we know, if we subtract and then we add a negative, those two mean the same thing. Okay? So here, What is 2 minus 5? Well, 2 minus 5 is negative 3, right? Well, 2 plus a negative 5 is still negative 3. So even though this one is in terms of addition and this one is in terms of subtraction, they still mean the exact same thing. Okay, so just keep in mind, it's just kind of a formality that we will keep vector addition always. So if it's a subtraction, it's really worked as subtraction. We just have to call it vector addition with a negative. Okay, so let me show you some actual examples here. So it says, let V equal the component negative 2, 5. So that would be in quadrant 2, because you're going left 2 and up 5. We could sketch that if we wanted to. And then V would be components 3, 4. That would be in quadrant 1. And now it says find each of the following. So letter A says 2 times V. So that means we want it to be twice as long as our original vector. Well, basically you just take the 2 and you distribute it, since it's scalar multiplication, to each of the components of V. And so our final answer is, if we distribute, our new component would be negative 4, 10. Okay, that's it. B is subtraction, so we're going to turn it into scalar addition with a negative. Okay, so that means we're going to take our W first. We're going to add and then negate our V. Okay, so if we negate our V, we got to do that first. That negative 2 is going to become a positive 2, and the 5 is going to become a negative 5. If you remember with adding polynomials, it's always the same concept there as well, where you have to distribute the negative first if you're subtracting. Okay, so our final answer, we're going to add our component. So the x is going to add with the x, which will give me 5, and then the y will add with the y, which will give me negative 1. Okay, so you see how it's pretty much just algebra. And then the last one is v. So I'm going to do negative 2, 5 plus 2 times w, which is 3, 4. So I'm going to go ahead and distribute here only. So I'm going to bring my negative 2, 5 down, plus, and then that'll give me 6, 8. And now I can find my final answer. So I'm going to add the components, the x's, and then I'm going to add the y's. And then that's it. Okay, so I'm going to have you try number 2, which is the same concept. It's the same process for the most part. You just need to write the final answer. Okay, now with this practice, I was going to try to get you guys to do it in a creative way, but honestly, I think I'm just going to kind of show you. It just says practice and sketch them. So if this is U, that's not U, that's a V. 2V would be like 1, 2. Oh, that's probably a little too. That one is as well. All right, so I need to kind of go like this. And then I need to do another one. All right, so that's 2V approximately. I'm not doing a great job because I'm not using a ruler or anything. All right, then negative V is just going to be the same thing. Remember, it's going to be like the same direction, but this arrow is going to be in the opposite direction. Okay, we want to try to keep them parallel because, direction is going to, if we keep them parallel to each other, that means they're pointing in the same direction. And then negative 3V will be like 1, 2, 3, just going in the opposite direction. Again, that's a sketch, so it's not perfect, but I think maybe you get the idea. I certainly hope so. Let me erase this so you can see the original. Okay? And then I'm going to show you one last thing, and it says, are the vectors u and v equivalent? So equivalence for like numbers just means, are they equal? 3 equals 3. 2 plus 3 equals 5. Those are equivalent. With vectors, because there are two pieces, meaning there are you have to have magnitude and direction. You have to show both of those things, okay? So is the magnitude the same? That means is the length the same? And then is the direction the same? Now, I don't know about y'all, but they look like they're going in the same direction to me. They look parallel to one another. But what does parallel, how do we show parallel? Okay, well, there's that word slope. Okay, so if they have equal slopes, then that means that the lines are parallel, which means they're going in the same direction. So for slope, we're going to show equal, for direction, we're going to show equal slopes. All right. If they have equal slopes, that means they're parallel, which means they're going in the same direction. And to remind you what slope is, the formula is slope is m y2 minus y1 over x2 minus x1. Okay? And then for magnitude, we're just going to do the Pythagorean theorem. And the way that we're going to show they have equal lengths is with Pythagorean theorem. Okay, just like we did in yesterday's work. All right, so let's first do the slope. So I'm going to use the slope of m. No, sorry, m is the abbreviation. The slope of u. And we're going to do y2. Now, I don't really care which one you call x1 and y1. I'm just going to kind of go like this. Okay, so this is my first set of x's and y's. This is my second set of x's and y's. All right, so let's plug it in. So y2 is -4, y1 is 4, x2 is -3, x1 is 0. So that's -8 over -3, and that just will stay 8 over 3. Okay, now I'm going to do the slope for v. So I'm going to do the same thing, x1, y1, x2, y2. All right, so y2 is -5, y1 is 3, x2 is 0 minus x1, and that gives me -8 over -3, which equals +8/3. So check and check. They have the same slope, which means they are pointing in the exact same direction. Okay? So now I need to check magnitude. Now here's Pythagorean theorem. We have to have a right triangle. Okay, so I'm going to try to zoom in here and draw my right triangle. All right, so let's see if I can count appropriately. All right, so that was 8, and this is 3. Okay, now this I'm not really worried about how you draw it. I guess I could have also gone like this, you know. Well, that wasn't very good, but this, and I still would have gotten the same numbers. Because I don't really care about the quadrant and whatever, you don't have to worry about if it's positive or negative. You know the reason why is because when we do the magnitude, whenever we square, whether it's a positive or a negative, does it really matter? And the answer is no, because when you square a positive or a negative, it's going to become positive. Okay? All right, so we get, what is that, 73. Now let's see if we get the same thing for u. Yep, so this is 8 and this is 3. So we automatically know that the magnitude of u is going to be using those same numbers, which will produce the same answer. Okay, so I just wanted to show that to you, that if we ask for equivalence, you really have to check for two things. You have to check for magnitude and you have to check for direction. Okay, so I would like for y'all to try 3 and 4. Similarly, to what we did yesterday. So you can just kind of put an imaginary new ordered origin there if you want to, or you can just try to count. It kind of depends. I'm not really trying to put you in a box. Like, you have freedom to kind of figure this out, or you could just go ahead and try to figure out the ordered pair like that. So there's a couple of different ways you can do that, but it asks for 3 things. So component form, magnitude, and direction. Exactly what you did yesterday. And then don't forget to go back and try number 2 as well. So there are 3 parts here, A, B, and C. Okay? Awesome, you guys. Have a great one.